Okay, so now we've got our setup produced in this software. We can have a go at setting some milling operations to enable us to use the CNC router to cut out this maze base design. So, first thing we need to do is understand how we select different milling operations and apply them to features in our design. It's worth noting at this point, designing for manufacture. So if you look at these channels here, I've actually designed this so that those are 6mm apart, which was initially for a 6mm diameter cutter, but I think we've got a 5mm one to hand, so that will work just as well. And that can also be used to bore out these holes for threaded inserts, and then also cut out the overall profile of the component. So in terms of order of works, I would get this central maze pattern machined out first, just because you could end up with such small parts, something breaking, and then it saves on wasted machine time had you done the holes in the outside profile first. It just makes everything more efficient overall. So the first thing I'm going to do is, and now in this tab here, there's loads of different things you can select, machining operations, 2D and 3D. Okay, so like contours, a great one for using within designs for vacuum forming patterns. For this, all we're going to focus on is a 2D pocket. So the first thing that comes up on here, I need to select my tool. So if I click select, it brings up this window. It may be blank on your computers. If you look at the left-hand side where it says cloud, there are loads of pre-designed tools in the Fusion library, but we want to have constraints to the ones that we've got to work with. So I've got a name folder directory here for the machine we've got access to, and then all the various cutters that I've been using. Now, within this project, I've already added one of those in. I can share a link to those cutters to you individually. So I'm just going to select this 5mm diameter cutter, which is an upcut. So that means that the flute, the spiral section on the shank, just below the shank, that's going to, as it's cutting into the material, it's lifting the waste up. Okay, so that does two things: helps extraction, prevents overheating and tool wear. Okay, so press select. So you can now see there's a mock-up tool head there and a cutting tool below. So the next thing we need to do, sorry, just worth noting, the feed speeds and the parameters here are preset. That's already been documented in by myself. So within the geometry, we want to select a specific geometry now. So it's important here, you understand you're not selecting the top surface. You want to reference the bottom. And you should be clicking on specified lines, not faces. Next thing we want to do is set the heights. So if I just look on the side here, so there's a couple of things to know here. The blue outline is the top height, and that's the top surface of the stock material you got in, and that refers back to the original setup that we put together. Then there is the feed height and retract height, which are together. So that is the height the tool will lift, the tip of the tool will be at when it finishes a machining operation, and the height it will move at when it's going to the next operation. And then clearance height is once all the different operations are finished, that's the height the tool will extract to, and then in the machine it will either go back to the home axis or it will move over to a different part of the machine bed and start work on a separate component. So obviously playing around with these heights, you can gain a lot of efficiency if you're manufacturing lots and lots of the same part or different parts, just manufacturing lots of things. So it speeds up the time and reduces Z height travel, which is quite time consuming in comparison to movement in the X and the Y axes. So moving over to the passes tab, tolerance can be left at the initial setting. It's worth noting here different types of milling operation. So so climb milling is essentially where the cutter is going sort of in the wrong direction, so it's not actually cutting into the material, it's working away slightly. The opposite, you wouldn't want to do that with a hand router because it can actually get thrown if it catches a knot in the material, but it gives the CNC machine more control. With conventional milling, your cutter's going into it, so if it hits any material or anything with irregularity, it can cause it to break or even damage the tool or move the workpiece. It's especially important to consider this when using a vacuum bed, which is literally where you use a vacuum to hold the material down in the machine. So we want multiple depths because we want to make this as efficient as possible without damaging the tool. So when you're using a relatively soft material, so a timber, a softwood, or a polymer-based foam, modelling foam, you can go at the full diameter of the cutting tool. So we can go 5mm stages. If you were milling a piece of metal or routing out some hardwood or really hard foam, you would want to go at sort of half the depth of the cutter. Well, it depends. It depends on the type of cutter, diameter of it, lots of different factors that come in. But general rule of thumb, with a fairly soft material, you can go at the diameter of the cutter, and it just prolongs the tool. So we don't need to leave any stock because we want to work to the exact geometry that we've designed. And then if we go to linking, what we need to do here is, now the safe distance, you might need to adjust that, and that refers to the height that it will lift the tool out in between moves. And then at the bottom we've got ramp type. So this is lead-in, transitions and ramp type are all about how the tool enters the material. Now a helix will actually do what it sounds like. It will enter the material in a helical fashion, but the issue is that channel that I've modelled around that maze design is only 1mm wider than the diameter of the cutter. So we really need that to be a plunge. It wants to go straight into the centre point of that profile and get cutting. So if I click OK, you can see it generating the tool path here. It's thrown up an error. From the highest Z position of the toolpath, the safe distance is higher than the specified feed heights. So what we need to do is just click Edit, go back to that linking tab and just drop that lower. I think the feed height was 5mm. So if we put that at 4. So what that refers to in the linking is the yellow lines you see on the screen now. So that's the movement of the cutting tool in between different operations within the same milling setup. So once we've got that positioned and that's loaded correctly, it's good practice to right click on that and press simulate and just watch that cut out our design and check that nothing's been missed, that it's retracting to safe heights and there's not an error. Okay. Yeah, that looks good. So we can speed that up to the finish. Okay, so that's a basic milling operation setup, and in the next video we'll have a look at cutting the other features out and then the overall profile and then how we get it sent off to the CNC machine.